Okay, guys. I'm Ethan Veneer, and for now, this is my associate, Dakota Smith.
What's up? Are you recording?
Today, we're going to show you force and other things. So,
It's only like a YouTube video.
come on, Dakota. Show force. Come on, bro. Come on.
Come on, this is pretty far.
Okay. See, this is Dakota. Now, if I push you like this, that's force.
Not even cool, man.
So, thank you for your time.
Yep.
There'll be more back. Hey. Hey guys, this is Ethan. I just deleted the other part because it didn't seem fair. So, I'm going to show you motion. Doing the Gangnam style.
Jake and I'm out, I guess. No, I'm not even gonna do that.
Okay. Okay, this motion. Suck, Dakota.
What is this?
That was motion.
Have you done
The
enough
Gangnam
motion
style
videos?
way. Okay, I'm going to show you an example of displacement.
You ain't showing it against me?
Before I get out of the way. Okay, so you got this ordinary chair. Just walk around it a couple times. And just keep going, Stop right here. And still keep going. And right here. That's displacement of 0. So I'm going to end the video now before she gets too rowdy. Okay, I'm going to show you gravitational force, which is, gravity pulling you down so you don't float away up into space or something. So I'm going to do this one simple way. Jumping. You jump, you come back down to the ground. So if you look down here, watch my feet. Let's jump, come back down. Keeps me down on the ground. So there's gravity. Here's friction, making my hands nice and warm because they're a little cold. So rub them together, makes everything nice, hot and toasty. And if you keep your hands loose, it keeps but if you push them together, it kind of makes it hard to rub them together. So
Yep, it does.
there's friction. Okay, since I have no way of actually showing you, I'm just gonna explain to you what buoyant friction is. Buoyant friction is either involved with water or air, and if something is sitting on the water and it's floating, kind of like a buoy, in the middle of an ocean or something. So, and if you put something in the water, it displaces water, so it pushes it out, so it kind of fits and floats. So
Yep, it does.
that's buoyancy. Hey, this is Ethan Veneer, here to talk about magnetic force. As you can see, this is Tori. So yeah, and then over here is Logan. And I'm gonna explain magnetic force. So magnetic force is you take a magnet and iron, you can do this at home if you have some nails or a magnet, and you just line them up or throw them down on the table, take the magnet, and you just wave them over, they stick up. So, and it's because certain things, because they have positive and negative charges, so opposites attract, and that's why when you put it over, the nails will just go up onto the magnet. So that is magnetic force, and talk to you guys later. Look at how gray. It's funny. Okay. Hey, I'm here to talk about elastic friction. So elastic friction is this little rubber band that Tori allows me to use. Pull it. It doesn't break, so this is rubber band. So you're pulling it, and it's just elastic, and
Twist and stuff.
it can twist and turn. You can use it for many things. Tori uses it for a ring. So is that, but
I use it for my hair.
okay, whatever you use it for, but it's what elastic friction is like. It when you pull it, it's basically it's like pulling things, and then it doesn't like it changes in shape, but it'll always go back to its original size. So best way I can describe it. So see ya. Alright. So there's story once again. Okay, so I'm gonna show you electrical force. So as we have Logan here and this balloon. So rubbing on his hair. As you can see, his hair sticks up. That's because of also friction. That's also because of friction. And since it's like, and it also has to do with opposite, negative and positive electrical charges. So when you're rubbing them together, it creates like friction. So when you release it, it still has all that all that electricity in it. So when you pull it up, it sticks up to the balloon because of the different charges. So thank you very much. Okay, I'm going to talk to you about centrifugal force. So it actually happens in our solar system. And this historian, she's actually going to help me.
What?
She says, this is Bob. So take this as the sun. Good job, Robert. Let me see that. Okay, let's take this as Earth. So the Earth goes around the sun, and it goes around.
Wait, this is the sun. Earth's little.
Okay, and the Earth goes around the sun, and the reason for
Gangnam
that is
Style.
because they have like
Go slower than that.
it
Let me see it.
just happens in our solar
Oh,
system,
you heard
so
him.
different sizes, and
the
since
big one?
gravity has to do with
Let me see the
too.
big ball. Look,
But-
big one.
That is centrifugal force.
Mm-hmm.
Our solar system.
Action.
Hey, I'm Ethan Bernier. This is Logan Sloan. And I'm going to show you what velocity is. So, velocity is the speed of a moving object. So, if I were to get up and run, I don't really have a speedometer or something to show how fast I'm going, but if I run like that, it's my feet are like moving fast. So, that is velocity. See you later. Hey, I'm Ethan Bernier. I'm going to talk to you about acceleration before my computer dies. Because
And this is Logan Sloan.
yep. And so
His right hand man.
so acceleration is like a change in velocity, either slowing down or speeding up. And
He loves me.
that's kind of weird, but it also happens if you're like turning around a corner, because you have to either slow down or speed up to go around the corner. So that's acceleration. Talk to you guys later. Hey, I'm Ethan Bernier, and I'm here to talk about momentum. So momentum is how hard it is to stop an object. So rather it's going slow or fast. And and honestly, I don't think there'll be any momentum to stop her. So, but that's momentum.
It's good.
Hey, I'm going to explain Newton's first law of motion. So, Newton's first law of motion says if the net force is zero, then like the motion of an object doesn't change, rather it's unbalanced or balanced. So, there's Newton's first law. Talk to you guys later.
Action.
Okay. Okay, here to talk about Newton's second law. So, the acceleration of an object is equal to the net force of an object divided by the object's mass. So, the direction or the acceleration stays the same.
It's like teddy bears.
Okay, so Newton's second law is the acceleration of an object is equal to the net force of an object divided by the object's mass. So the direction and the acceleration is the same no matter what. So So talk to you later. Okay, Ms. Bernier here to talk about Newton's third law of motion. So, Newton's third law of motion. Newton's third law is the object exerts a force on the second object. The second object exerts an equal force in the opposite direction of the first object. So it's basically like a gymnast you see at the Olympics. She pushes off of the balance beam or whatever, and that makes her like go up into the air and do whatever she does. So
He gave me
talk to you guys
$5,
later.
so I love him a long time.